Today we start a new chapter, Laplace Transformation. Let's start with the definition of Laplace transformation. If ft is a function where t is always greater than or equal to 0, then Laplace transform of ft, which is denoted as L of ft, and is defined as integration 0 to infinity e raised to minus st ft dt. Okay, it is also denoted as fs, f bar s, otherwise phi s. Okay, by the use of this definition we find the Laplace transform of some elementary function. Laplace transform of some elementary function. First we take f of t is equal to 1. Okay, put this f of t equal to 1 in the definition. So L of 1, right? F of t equal to 1. So L of 1 is equal to integration 0 to infinity e raised to minus st ft is equal to 1. So put down 1 into dt. So integration 0 to infinity e raised to minus st is e raised to minus st over minus s. Integration is 0 to infinity. Put down the limit of integration, 0 minus 1 upon minus s. So the answer is 1 upon s. So L of 1, so Laplace transform of 1 is equal to 1 upon s. Take the another function. Let ft equal to e raised to minus 80. If we put e raised to minus 80, so L of e raised to minus 80 is equal to integration 0 to infinity e raised to minus st e raised to minus 80, that is the value of ft, into dt. So what we get? Integration 0 to infinity e raised to minus st minus 80, take minus t common, so s plus a into dt. Now integration of this term is e raised to minus t a plus s over a plus s, minus of a plus s, and the limit is 0 to infinity. And then put the limit of this, we get 1 upon a plus s. Similarly this. So integration of Laplace transform of e raised to minus 80 is 1 upon s plus a, right? If there is a trigonometric function, take ft is equal to cos 80. So this is the third one. So L of cos 80 is equal to integration 0 to infinity e raised to minus 80 cos 80 dt. So e raised to minus 80 cos 80 dt, so that is the formula of e raised to minus st upon s square plus a square bracket minus s cos 80 plus a sin 80, and the limit is 0 to infinity. So put the limit of infinity first. Upper limit is 0 and the lower limit is 1 upon s square plus a square into minus s. So it will be s upon s square plus a square. Okay, similarly you have to find the value of sine 80. Okay, this is your homework. If the function ft is equal to t raised to n, okay, it is a polynomial form. If the ft is equal to t raised to n, then the Laplace transform of t raised to n is L of t raised to n is equal to integration 0 to infinity e raised to minus st t raised to n dt. There is one assumption, let st is equal to x, so dt is equal to dx upon s. Okay, the limit will be same, so L of t raised to n is equal to integration 0 to infinity e raised to minus x, so st is equal to x, so e raised to minus x, t is equal to what, x by s raised to n, and dt is equal to dx upon s raised to n, s common, it is constant, so it is free from integration, so 1 upon s raised to n plus 1 integration 0 to infinity e raised to minus x, x raised to n dx. This is the definition of gamma function. Okay, definition of gamma function. So 1 upon s raised to n plus 1 into, this is a function of gamma function, so it is gamma n plus 1. If n is positive integer, then gamma n plus 1 is equal to what, n factorial. So L of t raised to n is equal to n factorial upon s raised to n plus 1. Okay, this is the definition of Laplace transform of t raised to n. If there is an hyperbolic function, hyperbolic trigonometric function, suppose f of t is equal to sine h 80, then L of sine h 80 is equal to integration 0 to infinity e raised to minus st e raised to 80 minus e raised to minus 80 over 2 into dt. This is the definite formula of sine hyperbolic 80, e raised to minus 80 minus e raised to minus 80 upon 2. So it is 1 by 2 is constant, integration 0 to infinity e raised to minus t into bracket s minus a minus e raised to minus t into bracket s plus a whole dt. Now integration of that both term, what we get, 1 by 2 e raised to minus t s minus a over minus of s minus a minus e raised to minus t s plus a over minus of s plus a and limit 0 to infinity. Put down the limit of both upper limit and lower limit, we get 1 upon 0 minus 0 minus 1 upon minus of s plus a, so it will be become plus s minus a, and this is minus of 1 over s plus a. Okay, so taking the LCM of s minus a, s plus a, s plus a minus s, so ss will be cancelled, so it is 2a upon s square minus a square, so we get 2 to cancel a upon s square minus a square. Similarly, we find the value of f of t is equal to cos h 80, and it will become L of ft is equal to s upon s square minus a square.